Welcome everyone to SolidWorks Live Design. If you've never watched this show before, you're in the right place if you are a SolidWorks user. My name is Sean O'Neill, and today I am acting as host and producer of one of our community members. He's a Champions inductee, and he is here with his master's in robotics and autonomous systems, his mechanical design engineer job. He's actually taking the day off today. He's 2 months into his new role. He's 2 months into living in a new state. I'm so excited to introduce him. So he is going to be here to discuss and do a deep dive, of course, the theme of this year's live design on functional enclosures. He's made a lot of them in industry, a lot of them for just general purposes around his house. And I am so excited to introduce Sunday Ochedi. Sunday, what is happening, man? How you doing?
I'm doing great, Sean. How you doing?
Good. How's I mean, you're fresh in your new place, right? I mentioned I think you went from what, Chicago to Kansas City, what, 2 months ago, 2.5 months ago?
Yeah, that's right. The move has been like really shaky, and I've been working on quite a lot of stuff, like designing stuff, because that's what I like to do. So yeah, I'm really loving the move. Kansas is really great.
Yeah, I'm sure you're learning more and more about that every day. I remember I moved into my new house. I moved like 30 minutes away from where I was living. So like it wasn't a 30-minute drive. It wasn't that big a deal.
Yeah.
But yeah, you're always learning about your new neighborhood. But yeah, we are very excited to get to know you a bit better and also learn from your expertise. So I met you. I met you through, I saw many of your posts, many of your designs out there on your LinkedIn, which if you don't know Sunday yet, search Sunday Ochedi on LinkedIn. You'll see a lot of his SolidWorks designs, a lot of things he's made and created. But yeah, without further ado, tell us a little bit about yourself and, of course, why you're here today.
Okay. Thank you for that wonderful introduction. So,
Yeah, man.
you've said my name is Sunday Ochedi. I currently work as a mechanical CAD tech with a medical device company. So one thing you should know about me is that I really love design. So whatever I can do to like design something, bring something to life, I'm always doing that. I have a background in mechanical engineering, and I recently completed my master's degree in autonomous systems and robotics in Illinois Tech. And right now I'm just into like doing designs, learning. And what I do is to try connect with the community. I always like to post on LinkedIn, just as she said. So I'm always posting on LinkedIn just to connect with younger minds and try to like engage with them and kind of like learn and then let them learn alongside me as we grow.
Yeah, if you are interested as well, I mean, a lot of us have interesting setups. Some of us have very minimalist setups where we just work on our laptops like I used to. Now I have this like crazy setup with all these screens. If you're interested in a really neat looking setup, I think you have a setup. Not sure if it's your everyday setup that you posted on LinkedIn, but you had made a lot of different fixtures, a lot of different stands. Of course, in SolidWorks, you printed them and made them in a variety of ways. You have like 5 different screens going at once or something crazy like that. We'll show it later, but I'm not sure if that's your everyday or what, but so cool, man. But thank you once again so much for jumping on here. So you mentioned, and I've mentioned as well, that today's focus will be a lot about making enclosures, right? Could you tell us more about that?
Okay, so I am actually working on a project where I'm designing a monitor light bar because I actually just saw one online and I was like, should I get one? No, I should just make it. Yeah, it's
Yeah,
just like
dude, that's a question. That's how many of us in the chat have like had that same occurrence. It's like it's not even a cost thing, right? It's like this might just almost definitely cost me more money than to buy something that I could, but I kind of just want to make it. Yeah,
yeah,
that's a very common thought for sure.
it's actually the fun process to
Yeah.
like see something you design come to life. That's like really great.
Yeah, man. So yeah, do you want to jump into it? You want to like let's we were talking about this earlier. Let's maybe look at the I know you want to get into the methodology, you want to get into your sketching techniques, of course, with pencil and paper. You want to, of course, we're going to jump into SolidWorks deeply. But do you want to start off just by showing like a demo of maybe the SolidWorks model that we'll get into in a little bit?
Yeah, yeah.
All right, cool. Let's take a look here. Awesome. So yeah, what are we looking at here?
Okay, so this is the monitor light bar. I designed this as the enclosure. And let me just make this transparent a little bit. And then you can see all the electronics. So I actually designed this thinking about all the components I need to use and designed all those components in SolidWorks so I can make sure everything fits just fine. So this is the enclosure and this is what holds it to your monitor. Yeah. So in a few moments, I'll be diving into like how the design process, the thought process, what I do to get this enclosure.
I love it. A friend of mine posted on LinkedIn today. She was at a talk, and she mentioned that the person giving the talk gave a really sort of just remarkable quote. She said, "I don't want to leave. I don't want you to leave this space heavy on ideas and low on execution." And that's why I love today's talk because I feel like you're going to give us both. You're going to give us ideas, but you're also going to tell us how you execute and how people at home can execute too when they're thinking about building enclosures. So yeah, man, I'm looking forward to it. Let's get rolling.
Okay, okay. So first of all, I have a couple of slides that I would like to go through. And when I'm approaching design, what I like to do is I like to approach it as a mechanical engineer and also like an industrial engineer. And that you see in a couple of seconds. I'm hopefully going to try to like run through the slides very fast and then jump into SolidWorks because I know that's what everyone is here for.
I mean, the
So,
slides, a lot of the slides I've seen some of them. It's just diagramming and examples of your work and your sketching. So yeah, man, I understand. You're not this guy right here, Sunday, is not leaning on slides. He's giving you proof of concept of what he's about to do. So yeah, let's see it.
okay. Okay. So yeah. This is like just a presentation image I did, and I actually rendered this using SolidWorks Visualize. So
There you go. Jesse Sprague will be proud. He's a member of my team. Some of you have seen him, but yeah, he would love this.
yeah. Okay, so like I said, I like to like use think about design like a mechanical engineer and also an industrial design engineer. So what I do is I think about an idea. For example, I said the light bar design, and then I go online to like look for different like designs that exist, so I can like think around it and see what I actually want. So this is actually called a mood board. That's what industry engineers call it. They just paste in whatever image that relates to what they want to design or something they can pick an idea from. So that's what I try to do. And I also try to like make use of ChatGPT a little bit, even
All
if
right,
I,
yeah, interesting. What's it got for us here? Let's see.
yeah, so
So what
even
was
if
your so I taught a sort of mini course or presentation this year at 3D Experience World on different ways to use AI in a sort of SolidWorks context. And so I'm curious here, as many of us probably are in the chat, what was your prompt? Like what did you ask it for?
okay, so what I do is I just went in there and typed like futuristic monitor light bar
Oh, that's
design.
cool. Yeah, leave it. Sometimes, like I always say, like if you really know what you want, be very specific. But if you don't, and you want to be surprised or just get sort of loose inspiration, maybe again, be surprised, right? Just be loose with your prompts. So that makes sense to me.
Yeah, so I like to like play around with ChatGPT. So once I give it a prompt, I tell it to like do something. I would say maybe another, and then it comes up with a new picture, and then I tell it, okay, I don't like this feature, change this, and then so that's what I like to do. I like to like play around with the idea, try different things, and SolidWorks and ChatGPT keeps on spitting stuff out. So I just pick the features I want, and then I come up with my own like design based on everything I've seen.
Sweet. Yeah, it makes sense to me. So you got your mood board, which people use mood boards for like their lives, the future of their lives. They use it for projects, right? First time I
Yeah,
heard it, I was like, "What is a mood board?" Right? But you explained it so well. And then you use GPT, use a generative AI to kind of give you different AIs. That's part of your process today. So this is a very modern process starting out here. I love it.
yeah. So the next thing I do is try to uh, try to come up with the requirements I want.
Mm.
So what I do is I say okay, based on what already exists, as you can see this two monitor light bars that are already here. I look at this and this has a controller that controls this, and this controller is on the monitor light bar itself. So what I want is I want the lights. I want something I can control for my phone. I don't want buttons on the monitor, and I also want it to be powered from like my monitor and ease of assembly. And I also want it to look good. That's like what I'm looking for. So it's like the basic requirements. I want something that looks nice and functional, something I can easily use. So that's it. And then so once I'm done with that, yeah, some projects you do have like a whole lot of requirements, but I like to keep it simple because it's something I'm doing personally for myself. So I just pick a few features in it and then go along with it.
Yeah, man.
Yeah, so the next thing is like picking the components. And luckily for me, I already worked on like two different projects that I used LEDs. So I just went back to those projects and picked out two things I could use, which is this LED controller, and this is how it comes. But to design an enclosure, I just need mainly the PCB. So I stripped it and tear it down, and then got just the PCB. And then I'm using a DC to DC converter. This has a USB port, so that way I can connect it to my monitor. So basically, once I know these are the two components I want, then I start like doing sketches to like bring out the whole idea.
So you're kind of just taking into account with these sketches, you're just taking into account sort of rough footprint of the sort of interior electronics.
Yeah, yeah. So
Gotcha.
an electronics engineer will actually design a PCB to make it like slim, put all the features in there, but I don't have that skill, so I have to like go with off-the-shelf parts and just use components I can easily find online.
Okay, I was gonna be my follow-up question. So you're basically going online and just kind of getting these components, and then as you make your sort of rough blueprint for what you want to achieve, like you said, given your requirements, right? Aesthetically pleasing, of course, along with the other three, you are then you're gonna get going. So yeah, this is interesting. Cool.
Yeah. So I did a couple of sketches, and the first one you can see here is just like a basic sketch, just something completely straight. It's a rectangle, and that's based on most of the design I saw because they're just completely flat, just one straight, no contours or any deviation. So I thought about that, but based on my components I have, I wanted to make this as slim as possible and also a little bit different for what's in the market. So I came up with a few sketches, just did some sketches of what I would like. And what you can see down here is like the mount. I did a few sketches of how I should mount it onto my computer. So after doing that, the next thing I did was to I just jumped into SolidWorks to kind of like see what how they look like, but most of the concepts to just see how they look like and then decide on which one I want to follow. So what I did was after coming up with this concept, I actually sent it out to my friends, and
Oh, okay. So first you do generative AI sourcing for the ideas, and then you refine it, and then you're like, all right, friends, let me know what you think. Let me check in with the humans.
yeah. So I send this out to them and tell them, okay, this is what I'm looking at. I want to design something like this, but which one do you think gets like uh, resonates with you? Which one it's easy, simplistic? Because that's the most important thing about design, making something simple but still eye-catching.
Sure.
So most of them like looked at it and then told me that okay, they actually prefer the second concept, I
The
think.
second concept. So that's concept two.
No, the fourth concept.
Oh,
Sorry.
concept 4. Okay. So your friends preferred, and let us know in the chat if which one you preferred. Obviously, this project's over. It's done. We're about to dig into it in SolidWorks, but let me know if you would have gone with concept 4. Let Sunday know if you're like if you're like his friends apparently, or if you have other ideas. We do have a question here from Shoggy. If I'm, I apologize if I'm mispronouncing your name, but let's get to it here. So, Shoggy asks, do the components limit your design, or do you design and fit the components later?
Okay, so they actually do limit the design, but
Okay.
something I like to consider first is to, like, if you do have like the physical components itself, you can like stack them up and look at how you want to position them. Yeah, so the main thing is I wanted it to be slim, and then I
Mhm.
considered how I could place those components to be that slim. And that's what, like, if you notice this, you have this bump up here. That's why it's there. All these bumps, that's why it's there. So I can stack up the electronics, and
Ah,
then
I see.
yeah. So I just need, so the idea is once I have that, I could just make adjustments to like the height and slightly the width to like adjust everything. So it does play a role. It does limit like the design process, but not that much for this particular design.
Sweet. Awesome question, Shoggy. Thank you so much. And for the rest of you, that's why we're here together. We're here just to share knowledge and have some fun. So if you have questions, if you're on YouTube, go into YouTube, ask a question, make a comment. We'll be sure to take a look at it here on air here on the live stream here on Live Design. So yeah, that no, that makes perfect sense to me. And just like you said, like getting back to your requirements, right? Kind of leaning on those requirements as like the 4 pillars of what is going to make a successful design for you in that moment, makes a ton of sense for me.
Yeah. Mm. So like still on the topic of limitations,
I mean,
actually.
yeah, I mean, constraints are huge, man. This is what it's about. You always have constraints, so for sure.
Yeah. So, like I mentioned before, still relating to the question that was asked, you have like size of the components. They do affect how you design, and then the assembly method you want to use, and the material as well. And one big factor is like manufacturing method. How do you want to manufacture it? For this project, I aimed at like using a 3D printer. I actually used the Flash Forge Adventurer 5M Pro. So which has like a build plate limit. You have the build volume limit there. So you have to design around that to ensure that whatever you're designing fits into that. And as you can see from the images I have, if I were to like place it completely straight, no, I wouldn't be able to print that. So I kind of like rotated it. And this actually played a role with like the dimensions of the monitor, the design. So that's what you consider. So manufacturing, the size of the components and stuff like that, they're always important when you're doing the design.
So Sunday, we have some people just joining. Yeah, if we could take a look even at the SolidWorks model maybe one more time before we jump into it pretty soon, just to show people like what we're talking about, and maybe because I have a question here as well. So you mentioned, of course, the sort of build volume of the 3D printer. That is, of course, of consequence here, given what you want to use, type of material, the type of manufacturing. How about I mean, of course, you could print this. I'm not saying it's like a good idea, but like you could print this in a number of different pieces and then adhere them together. So was your goal? I'm guessing in this instance, you wanted to have one continuous print.
Yeah, yeah. So I actually wanted to have like a clean look. So
A clean look, yeah, that wouldn't be as clean, right? Or it would be really hard to. You'd have to do a lot of more steps just to make it look,
yeah,
kind of make it
so
look like what it isn't, which is again a continuous kind of surfaces and that kind of thing.
yeah, so aesthetic is like I mentioned in the requirement, aesthetic
Hmm.
is like really important to me. So I wanted everything to be like one piece. So I can easy it has like a clean look and basically it's appealing to people.
Cool. Yeah, man. Thanks for jumping back in. We'll be back in SolidWorks, of course, very soon. But yeah, let's take a look. If you have more kind of pre-steps to look at, let's take a look.
Yeah, okay. So, like I said, and manufacturing is really like very important, something you have to consider when you like choosing your dimensions and stuff. So, uh, the next is like I looked at like existing design, as I've said previously, and then I looked at the dimensions of like most of them that existed, and this is basically the dimension I found for most of the monitor light, by the way, within this range. So I decided to go for something like maybe slimmer within that range, but try to like accommodate my components and stuff like that. And that's what you see here. Uh, this is kind of like my dimensions for like the starting the design and then changing, and you can see this is my the total length of the design, and this constraint comes from like the manufacturing I already discussed before. So
That
that's
makes
one.
sense.
Yeah. So now to the part where everyone has been waiting for.
All right. So this is so we talk about there's a lot of different ways that we talk about these sorts of this specific phase of the process, right? Where you don't just jump into SolidWorks or a tool like SolidWorks and just start doing stuff, right? Typically, you sort of have your phase where you're thinking through what is the structure going to be of like my serious model. Like you said, like you were sketching some stuff up in there, you were shooting things, you did a rendering, send it out to your friends. But like as you start to think about more in like part assembly, sub-assembly structure, like how are you going to get into it? It's like a pseudo modeling step. So yeah, talk us through it.
Okay, so I actually use the top-down approach and do a lot of in context like modeling and stuff. And although I'll still talk about like assembling the component, but right now let me just jump into SolidWorks and show you a little bit of what I did. Uh, so this is the like the final design that that currently have this like the assembly. But before I got to this point, I started with this.
So this is kind of like one of the base models, like one almost like one of the renderings, sort of that you send out to your friends, right?
Yeah, yeah. So this like the master model I used, and from this I kind of like did so many other features, and then to like bring it to what we have right now. And one of the first things I did, so let me roll back and then go through some of the features. So you can see this is just a chunk of block.
Yeah, it's come a long way.
Yeah. So that's one thing with like designing. You have to think your process through. Sometimes you can't, so you just just jump into it and do whatever comes to mind. And that's what I like to do. I like to play
So
around with blocks a lot. So I just
for our beginner users, a lot of us who have been designing in SolidWorks for, let's say, maybe over 2 years or so consistently, they might know why you did this. I have an idea of why you did this, but this is often referred to as like your base feature, in other words, the feature upon which and from which everything else will be built, right? So
yeah.
why did you choose a rectangular prism for the base feature in this case?
Okay, so because basically what I was trying to design, it's the main shape is actually a rectangle before you add any
Where you start
other.
taking stuff away and
Yeah,
yeah.
so basically just a block, and then you cut things away, chamfer, fillets, and that, and then you get whatever you want. So that's why I started with this. It's like a simple way of like going into the design.
Gotcha. Josh has been there. Here's a pretty picture. Now engineer it to make it real.
Yeah, so once I had like the square, there's like the limit I want to go. So
Hmm.
this way I can easily come back if I want to adjust my height, my width. I can easily come back here and just adjust it, and everything changes and updates. But SolidWorks, you must always have some features that fail no matter how you try not to. But yeah,
Yeah,
I
yeah.
there like a few features that failed, but not so much, and just easy like modifications and then you're done. So um, yeah, my design thinking here was quite okay. So and then the next thing I did was to like cut out the cross section. And so like just a little bit of context. What I did was since the design is meant to be like symmetrical, so I'm like starting by designing just half of it, one part of it, and then I can mirror it around and then get like the full design. So this is like uh half the design. And then so right now we're getting to the shape we know and love right now. So
Yeah, but it's crazy. Like it never it still amazes me, you know, however many years of using SolidWorks, how things can really take shape from the first feature to the second feature in a tree. Like you
yeah,
went from just having like a rectangular box where again, if you're a beginner user, I would think a lot of people are like, why didn't you, you know, make this a different shape, or why did you choose that specific length of the shape? And then like as soon as the second feature rolls down and and sort of develops and, you know, loads, it's like, all right, I see it. I see where you're going.
yeah. So after the next thing I did was to like do some fillets just to get this curve. And most of the times it's always like good if you have your fillets at the end of your process, but sometimes you can avoid it, or sometimes you just want to like see how the design looks, so you just put it in and see if it goes well. I think that was actually the case here, so I just put in the fillet there. And also considering the fact that I'm going to do like a mirror, I just want all the features to be like there. And so I added my fillets to get like the nice cover the edge, and then some chamfers. So, and now we're really looking good. So it's
Yeah.
getting close to yeah, what we have. And I think there's another layer of fillet. So we have this, and I was pretty much okay with this. And the next thing I did was like mirror it. So we have like the complete uh, enclosure design. But everything is still solid inside. So this is actually what I sent to my friends to like, okay, take a look at this. Is it nice? Is it okay? And they give me a thumbs up. So I went with this design. Yeah.
Yeah, it's we've all been there. Let us know in the chat if you've been there. I mean, I think we all have been, where you like get to a point in design where you're like, all right, good enough to show people. Good enough to get external advice, right? You don't want it to be too late in your process. You don't want it to be too early. So you kind of get to that point where you're like, I know I'm at that point right now. So that's a good thing to share, I think. But yeah, and I'm sure your friends, you know, hopefully they've had a hand in a lot of your designs. I'm sure, in making them better and making them, you know, ready, obviously, for you to create, whether your industry designs, the ones you make for your own personal purposes. A lot of them, though, we've seen, and it's actually how I came to know you, right, on your LinkedIn, right? So I wanted to just take a brief a minute here, just to plug you. I usually say this for the end, but you have a lot of really neat designs here. You know, maybe you could talk through a couple of them here as we kind of cycle through.
Yeah, so most of my designs are actually inspired by some things I see, and some of them are actually products. And most of this design you're showing right now, like this one, they are like designs I did way back when I started using SolidWorks. So it was kind of like a learning process, doing a lot of stuff. Just this was actually one of my first design, which is like really not that great, but over time I got good. Try to integrate like mini industrial design stuff with, as well as mechanical design stuff. And one thing I always do is I never shush someone when they're trying to explain something to me, even if I
Mm.
know it's a process of learning. The person has like a different way he does something. So once the person says it, I get that idea. It's like an extra tool in my like toolbox. So yeah.
This just before we get back to SolidWorks here, this one really blew up. Yeah, this setup here. Let us know in the chat if this is a bit too much for you. If you would love this setup, I know we all have our preferences, but tell us before we go back to SolidWorks. Just tell us a little bit about this. Let's spend some time here because I think a lot of us would be curious about this.
Yeah. I actually had a lot of people in the comment like complain about like too many screens, and I had to like explain to someone that all the screens there have its purpose. Like I said, so my I have my two monitors there. That's basically where I do my design and stuff. And then my laptop on the side. So I have everything I need on those screens. So I use one monitor to like work on SolidWorks, use the other ones to like open like maybe specs that I want, maybe looking for components that I can fit in online, stuff that I could buy. And then I have like a Samsung tablet there, and then a Surface Pro. The tablet is mostly for sketches. I just put up a sketch there that I want to like design. That's if I don't have it on paper. If I designed it using maybe SketchUp or something, I just put it there and then use it. And then my Surface Pro is kind of mostly for when I don't want to be on my desk. I, yeah, I just want to do a few stuff, so that's when I use that. And I also have my printer software there. So once I want to like slice something and print it, I just use that and stay in my bedroom and do that. So yeah.
Uh, That's cool, man. We're getting some comments here. Saw this post. That's a good setup. Beautiful setup. So yeah, once again, I had to show you some love. You have some really great designs on your LinkedIn, and again, we usually say that for the end, but by the end, we all know like not everyone's always there at the end. So we kind of wanted to do it as like a bit of a segue into the next part of the talk here. So once again, look up Sunday Ochedi here on LinkedIn. Stay connected well after the live design. So now back to CAD.
Okay. So after doing this, the next thing is to, because I already had this set up, and the next thing is to like shell. So that's the next feature.
Yeah, this is like I'm always anxious at this step. Like
Yeah,
it's gonna shell or gonna be some. Although I would say in recent years, I feel like the SolidWorks has definitely gotten better about telling you like what doesn't work.
yeah,
If
yeah.
something doesn't work.
I think it mostly has like the shelling feature mostly have problems with like your fillets. That's like,
Yeah.
yeah, yeah, you have the
That's
major.
that's what made me nervous about this one, but no, you got it to go and looks clean.
Yeah, so you have to play around with your fillet to ensure that you get something good,
Mm.
especially like this point. So there's one important thing when it comes to like designing to produce, especially like DFM, when you're trying to do injection molding or something.
Uh-huh.
So yeah, you have to have like completely uniform wall thickness.
Mm.
That's like one of the stuff you need to do. So in some areas you might deviate from that a little bit, but it's always advised to have that. And the shell feature actually tries to do that, and that's when you get an issue if the fillet maybe the fillet is too small because it uses the outer fillet depending on if you're shelling inwards or outwards. So it uses the fillets that and diameter some or radius. So you have to like adjust to like fit into what you want to and ensure that you have like a good shell feature and stuff. So in my case, I'm using like a 2 millimeter thickness for like to have my for my enclosure. So uh I'll still
Yeah,
talk
and that
about.
that property, I just wanted to say, I mean, that property manager is pretty simple. Like, there's not much going on. Like you said, you define the wall thickness, any faces you'd like to remove, which you don't have to, like you know.
Yeah,
And then yeah, a couple others there. You could do right like multi-thickness
yeah,
if you wanted to have differing thickness at different areas of the model. But yeah, no, that's a really good tip, especially in regards to like you said, DFM, design for manufacturing, within those contexts. I wanted to ask you in terms of how you kind of acquired some of this knowledge and some of these skills. Like, is this like in terms of making enclosures? Do you find you're doing them more for your job or more for like personal purposes of making sort of personal projects these days? Or is it more so, or maybe equally so, like in your work, more so as part of like your day job as a mechanical design engineer?
so it's more like mostly personal and then a little bit of like work stuff, but yeah, more
We
personal.
could probably have you back for a whole lecture on robotics, which we probably have to at some point.
I would love to be back.
Yeah, man, this is great. I'm having a lot of fun. So we've just shelled the model. So where are we going now?
So now I'm trying to like make a cutout for the lights, the LED lights that I'm supposed to put. Yeah, so this is the cutout I made here. So
Oh,
this,
interesting. I see.
yeah, that's where the light is supposed to shine through. It's And after that, I think,
All
let
right.
me, yeah.
So let's see where we are now.
So yeah, this is the next process. And this is kind of like a platform where I could like lay. I'm actually using an acrylic sheet, so that's where I place the acrylic sheet, so it's transparent to allow the light like flow through and also hold the light in place.
Oh, okay. So that actually represents a different, like you said, an acrylic. So that's going to be a different type of material. But as so far, obviously, SolidWorks wise, you haven't defined a material, and that's fine for the purposes of why you're doing this.
Yeah,
Um,
yeah,
so that's that's good to know, though.
yeah. So I mostly define materials when I want to like know the weights and stuff like that. But
Sure.
most times I like to like print with PLA because it actually does. It's actually good for a lot of stuff I do. They don't really have like much engineering requirement. That's most personal projects I work on. And even if they do, I kind of play around with PLA to like get what I need, like a sweet spot.
Mm-hmm.
Yeah. So this, I did a few fillet features to like shape the way it is, so it looks a little bit nicer outside to like follow this curve. Yeah.
Now you
So
are, of course, like this is an enclosure for LED lights, right? So I guess at this point you are considering how the light will cast in this sense, right?
yeah.
Cool.
So the next thing is to actually like uh from here you could actually move to separating this part, like splitting the part. But what I did was I created some like extruded bosses for screws, which you can actually use a SolidWorks feature, which is the fastener feature, and just do mountain bosses. Yeah, but here I just did an extrude myself, so I'm actually
So
playing with yeah.
that feature, man, it's like I haven't seen anyone use that feature in so long. Let us know in the chat if you do use it. But yeah, that's definitely a rarity and a bit of an Easter egg during this episode for sure.
Yeah. I'll actually show because I actually used it somewhere else in this design. So
Oh, cool. They're gonna see it.
look at it.
Very nice. Very nice.
Yeah, so I did this and then just did mirrored it.
So you got a pattern and then you've
So
mirrored
I'll
it.
try to go a little bit faster so we can. And then now the next thing is to like split it. I have to like split it into two parts, the which is like the top and then the bottom. So we use the split feature, but I don't actually know where to find this. So most times I just use the search command because I know what I want to just split and then it comes up.
I mean, that's honestly like even I work at SolidWorks. That's still, I mean, it's still the same thing. It's like if you know where to find your S key on your keyboard, you know where to find almost everything. Especially now, just to drop a quick tip that we came out with just a few iterative releases ago. So it's in, I believe it came out in 2025 SP2 or FD functional delivery 2. If you're there, we're just at FD3 now. So if you have either of those, we actually have improved command search. So if you go into your options, like on your SolidWorks license, and you go, I'm sorry, if you go into customize, so tools customize, we're just same spot where you would go and apply or look up keyboard shortcuts. So under the keyboard section, you can now add sort of extra search terms. So like, for example, if something extrude boss, like it's like, it's not sticking for me, right? Maybe you say like material or like add. You can add these extra words to where it will come up even if you search for those words. You do that as like a CAD admin too. So split's pretty obvious, but I would say like you're splitting bodies. but maybe
Yeah,
it's not. I don't know. So, but no, I just wanted to throw that out there.
yeah, that's really cool to have. Yeah, so when you're using the split feature, normally you can like assign title to it, and what it does is once you click OK, it saves the body separately, like into separate files where you can name them what you want. But here I'm not actually doing that. I don't want to save it into like separate files yet because I still have a lot of stuff I want to work on before saving it as a part file that I can further later on work on. So what I do is I don't click on the assigned name. I just click on the two components I want. These are the main components. And we have all these other components because of the extruded bus I did, and then like did the linear pattern. I didn't merge them with the existing parts. So that's why we have like a lot of them there. But
Okay. So they kind of act as like body splits in and of themselves here.
yeah. So I just took like the two I needed, the top and the bottom, and then we clicked on OK. So it splits the bodies, it splits them into like two, it splits this into two bodies, but you also have like the other linear pattern and stuff you have there. And that way I could like work with two of them. And the reason why I didn't save them into like different parts already is because I wanted to add like a lip and a groove. So this components can easily mesh together, and you can like screw it easily. You don't want like a flat stop or something.
That's a
So
wise approach. I mean, you mentioned at the very beginning, you mentioned, your plan, your sort of pseudo modeling plan was like, I'm going to maybe use some in context features. I mean, split in a way is kind of like that, right? You're basically just building everything within the context of itself, the original context. And so once you break them out into their own part files, well, of course they're going to, like, unless you alter them after, right? It's like, of course they're going to fit together. They're built together. So
yeah,
I think that's a pretty wise approach.
yeah. And I did it this way so I can easily, if I notice something with the assembly that I want to add, that I can actually do it in this main master model. I
Ah,
just do that, and then it updates in the body and goes back to the assembly. So it's like it's something easy I can like work on. So the next thing I did was to like do a lip and groove. The lip and groove is basically just so they,
lip and groove. Look at
yeah,
that.
yeah. So
Man, this is another one. No one ever uses this anymore.
yeah, actually, yeah, before I do like I do this myself, like come up with a sketch and then try to do the home and dimensioning behind that. But with the fastener feature, which is here, you can just go down to lip and groove, and then it's an easy tool to use. You can just do whatever, play around with it and stuff like that. So this is how it looks like.
That's a great use for that tool. Yeah, now I mean, yeah, look, if you guys have FT2, FTO2 right now of 2025, just add that extra shortcut for the search menu. Just add Sunday for lip and groove. Forget the name, you'll remember who said it. So
Yeah.
that's a great use of that tool. How did you, just out of curiosity, like we're all learning at different paces, different times, different years. Like were you just kind of looking around for, that feature, for the mounting boss feature? Like how did you come across those initially?
So I've actually forgotten, but
That's fine.
but
I forget a ton of stuff.
I think I got it from a YouTube video because, like I mentioned before, I always like to like look at like design videos on YouTube. That's like a good way of like improving yourself because
Oh
you
yeah.
end up something that you might use later on, but you don't know. And then when you're working on a project that comes into your head, you're like, yeah, that's good. That's good.
And if
Yeah.
like, and I know we've all been here too. Like if you don't remember exactly what happened, that's what your YouTube history is for. So
Yeah.
just find the video, rewatch it.
YouTube is like a really good tool, so
It
you
is.
get a lot, and SolidWorks have a lot of people that are like posting videos, so it's like easy for you to get what you want. And if you don't see it, what I always like to do is like spend a few hours playing around, and then you finally get it. And once you get it, it's hard for it to go.
Yeah, man, you can always do file new part. You
Yeah.
can always do file new part.
For some reason, the feature is not actually opening. I don't know why. So I think
That's
I'll just keep it for now.
what was
Sorry.
what was the intent of that one there?
Huh?
So that feature, what was it? What's it doing?
It's like the leap and groove feature is just you just add a little bit of like what the thickness you want to leave, this height, and then the distance you want to keep between the two components, just like clearance, so they can like fit in together. And when you're doing this, you also consider like the tolerance of what your the same manufacturing method. For me, since I'm going to be using a 3D printer, I consider that. I normally give between like 0.2 to 0.5 because that's what I found that most of my printers are within that range. So whatever
Mhm.
I do that way, it fits in. So that's what I do. And then here as well, so it mates and you have this flush to this. So that's why you give like a gap here. Because if it's completely on this, like I said again, your manufacturing method may actually and ensure once this face touch, there might be a gap out here, and you want to make sure that this is completely sealed outside. So that's what I consider. And yeah. So after this, I just combined combined the features I have, and then I saved the body. So to save your bodies, what you do is you go to the solid bodies here, and so you just right click and then you have save bodies. So once you do that, you can save them and give them whatever name you want, and then it's saved. And this is actually good because whenever I come back here to like make change, all I do is just roll this back and then do whatever I want and then drag it back. It saves back to the part I already have, and then I can use that in my assembly.
That's yeah, it's very cool. It was like when I first started learning SOLIDWORKS, like the history-based nature of this and how you can use that to your advantage with the rollback bar. Yeah, I continue to, all these years later, I continue to appreciate that to this day. And I wanted to mention too, like you mentioned, save bodies. Of course, you just go up to the bodies folder, which will automatically, by system default, display if you have more than one body in a part. Similarly, if you go up to that same area, you mentioned doing two combines here, two combine operations. Those sort of Boolean operations are very similar in terms of their accessibility. So they're right by the bodies folder, right? Like
Yeah.
you can select like multiple bodies, control select, shift select, whatever it is, right click, and you got just like you showed, right? Sunday on the save
Yeah.
bodies, you got your combine right there. So cool. That's a day in the life
Yeah.
of this multi-body part. So awesome. So I got nice explanation. Save bodies is a great feature. We're getting some comments here. So awesome. Thank you guys for commenting. And once again, I have a lot of my curiosities. You guys have asked some great questions already, but please feel free to continue asking questions as we go here. Very cool.
So I wanted to give a little bit of context for like the combined features, and you
Oh,
have
sure,
two.
yeah.
Yeah, we have two combines because we have like two components, majorly the top and then the base. And remember, before I did like an extrude where I wanted to put my screws and stuff.
Uh huh.
So I also split this. So you have them split. So the combine is to like combine the top part of the bus to the
Oh, with their associated top or bottom pieces.
yeah, and the second one is to relate it to the base. So yeah.
I see.
Mhm.
Awesome. Yeah. Thanks for exploring that. I actually wasn't clear on that either.
Mhm. So let's jump back to our main model. And now, so the next thing I'll do is kind of like go through some of the components. And like this is the top. Mhm. Yeah, I guess it's updating because of like some of the features I touched in the previous
You
one.
got a lot of linkages going on here.
Yeah. So this, let me just scroll back a little bit and just show. So this is why the safe body is good. This is what comes in from my master model, and so I can like work with this and see. So uh
You see the you see the desire inherently to do that too. I mean, like, look, like you started off that part and you already have that sort of your base feature with your last part was a rectangle, and now your base feature in this one is like a very well completed or very well progressed top part of your design. So I see that very well. It's very nice.
yeah, thank you. So it's just when you're designing, you try to make everything as simple as possible, so you don't have like a lot of features lying around and making your like computer run a whole lot. Yeah, so that's what I try to do, and these are like very good practice when you're designing something. So next, I wanted to like add some like features that when you're considering designing for injection molding, so you can't always know everything you want to about injection molding. That's the thing. You always need manufacturers, but it's always good to like have an idea of some of the things that need to be in place. And then when you speak with the manufacturer, they can like point out a few things for you to like stuffs you need to adjust and so on. But so for this, I needed to add like ribs, kind of like to structurally make the sound. So
Sure.
if I'm printing with like small dimension, like 2 millimeter, the rib will like support it. And to do that, I used the rib feature. And for the rib feature, you just have like a sketch, which is just a line. I did a couple of lines and then use the rib feature to like extrude this down. So it's
Yeah,
like,
rib for plastic parts, like you said, in terms of adding structural integrity, it's such a great feature. I mean, essentially, it's just sort of like up to next and then up to next, right? It's like up to next in like direction to the sketch segment and up to next sort of parallel. Usually, I guess that's how it's used anyway, like parallel to the sketch plane surface. So yeah, great tool for stuff like this.
yeah. And most times it doesn't always work like the way you
Not
imagine.
always, yeah.
So
There's a lot. I always find like there's just like a lot to think about, you know.
yeah,
There's a lot to consider, but yeah, when it processes and the conditions are met, it usually works pretty well.
yeah, yeah. If you have a simple design, simple feature, it can like work right off the bat, but sometimes you just have to like play around with it and then you get what you want.
Yep.
Yeah. So just playing around with this and then cut them to like shape the way I want it to be to like structurally support this. And there are some designs that actually have some going vertically this way, but I wanted to make it like a little bit simple. So I just did this. I don't need too much feature. It's not really that important for my case. And then I mirrored these features to this other side. Remember, I said this is symmetric, so most of the stuff I'm working on can be mirrored. So I mirrored this. And then for this part, I also did like a rib, as you can see, and then cut it to like fit what I want. And then these are some draft features I did, but I'll talk about that later. For now, I'll just skip that. I'll talk about the reason why I used draft, and it's basically just for DFM for your manufacturing. And so, like, this is the boss feature I told you about that I'll still come to like talk about it. And what I did here is there are like two ways you can use it. You can use
Mhm.
it for your screws. You can also use it as like a pin where you have something just supporting like
Oh yeah.
components. Yeah. So components that have just small holes that you can actually drive a screw through. So they are very useful. Pins are actually very useful. And to use this feature, so this is how it looks like. These are all the parameters you need to put in, so you play around with it to like get what you want, and this is it. So and then you can, so let me just go through it a little bit. So here
Yeah,
you actually,
it's a great tool. I mean, it's like it kind of is reminiscent of using like the design library to add different like feature collections into a part, but it's fully curated for this specific type of workflow. Yeah, it's definitely an underutilized tool for sure.
Yeah, yeah, it is. So you have like few features here. You have like a position. For this one, I use the point. So the point, you can like dimension it to wherever position you want it to be. And then you also have like the pin, and then this is like a hole, depending on what you want to create. If it's for a screw, you go with the hole. It's for like the components you just want to support, simply you go with the pin. And for this case, I use the pin. And then you also have like the height, like the complete total height of the stuff, or you want it to actually go to a face. In this case, I'm using the face, and the face is actually the electronic component which comes from that my main assembly. So this is like in context here. So it's coming from the assembly, and then you just play around with these figures to kind of like give the shape you want to fit into what you want, the components you want to hold. So that's just the basic. And then you have like fins here, kind of, that you can use to like support this. So once you put in features like this in the component, it's always good to, because of injection molding, it's always good to have like wall thickness that aren't really like that less than your outer wall thickness, your
Mhm.
enclosure thickness. There's mostly a guide of like zero point 0.5 to like zero point 0.6. So whatever walls you build in India have to like be within that limit. And that was also done for this ribs that I put in here. So you also have that condition for those ribs.
Yeah, I see that.
Yeah. And okay, this is still for the pin because of the components I'm putting in here. And then this other one, this is the extrude bus for, this is supposed to house a screw.
Hmm.
And mainly it's supposed to house a threaded insert, because that's the way I want to assemble it, a screw. And then
Sure.
yeah, and threaded insert here. And this is how it looks. For here, I kind of like used a circle for my points, and then the face I want to make it to. So it's basically the same feature, it's the same thing. You just have to play around to get what you want. And once you're doing this, so one thing I like to consider is when you're trying to put your bus for to mount your screws, you're trying to put a threaded insert inside it. So you're supposed to like melt part of the plastics to like hold your threaded insert. So what I like to do is, instead of giving the diameter of the hole for the and threaded insert to go into, instead of giving it the same dimension as the threaded insert, I like to
Mhm.
like uh add like maybe zero point 0.5 interference, so the threaded insert can actually go in. And the
Sure.
reason, so yeah, when you apply heat, it melts around the area, and those
It's a great
melted
point.
part, it holds the threaded insert, so you have it like fit snug into the component. You can easily like remove it out. But one thing with threaded insert, you also have to be careful, because torque is one important thing. If you tight your screw too hard, it might actually twist everything and just bring out the insert, because some of them are not really strong, but when they are injection molded, they're actually like pretty good.
Yeah, I see. Shoggy mentioned, I think Sunday is in the plastic molds field. I wish he can give us some tips about the domain in a future meeting. So yeah, there's uh, a wish for more to come. So that's great, man.
So I can give few tips, but I'm not really like really into it. You actually get more from a manufacturing engineer, because they know a whole lot about this stuff. And whatever you're designing, you just do with some of the few knowledge you have. And most of them are actually learned from YouTube, attending webinars and stuff like that. And then also talking to engineers as well. I like to ask questions. That's that's one thing about me. So that helps out a lot.
That's awesome.
Yeah. And so the next thing I did was to like add like holes for the kind of screw I wanted to put in. There's already a hole here. So what I just wanted to do was to uh add like a countersunk here. So this is to enable it's so that once I screw in like everything, assemble everything, the screw can be like flushed with the surface, so you don't have the screw like coming out, and that's why I used like a countersunk screw, so it fits in here. It's just okay. You have like a smooth surface up top, and the
Interesting.
reason. Okay, go
So,
ahead.
so did you add the countersink after adding the cut extrude for the holes?
Yeah, I already added the hose, so I just added the countersink. But you can actually do that without adding the hose. So that's actually the best way to go. But I already did the process before, so I didn't want to like go back
No, I,
again.
I completely understand. I was asking mostly because I was trying to see if like there was something that I didn't know like about like a process of doing that for some reason. But no, that makes sense to me as well. I would have done the same thing. Especially if there's like already references built into the cut extrude. Like I might have been tempted to do that as well. So that's okay, awesome.
Okay, yeah. So this is basically how it's basically your whole feature, and I think. Yeah, so there's something I wanted to show. I guess maybe I'm picking the wrong one, but it kind of gives, there's a feature you choose that gives you clearance for like screws to go in. So SolidWorks has one whereby you just get the exact, like for this I'm using M1.6, so it has the one where you just have like the exact 1.6, and then it has the one where you have like a clearance for the screw to go in. So basically that's what I do. But for some reason, most of this I don't memorize most features. I just go in there, play
Yeah,
around with them.
give yourself a break. There's a long feature tree.
Yeah.
So yeah, we're getting it. So I get see a ton of fillets there to kind of finish it up, I presume.
Yeah. So I'll just skip through a lot of them because they're basically just generic tool we use. Okay, so this is actually important. So I did a cutout for my USB cable to
Ah,
actually,
oh,
yeah,
sure, that's important.
yeah, to connect to my module. And then I also did a cutout here, just slight extrude. Uh,
So those two on the back, what are those for?
so those are actually for magnets.
Ah, okay, that makes
Yeah.
sense.
So I wanted to, put in like magnets. So the magnet snaps to the other components that's supposed to like go to, that's supposed to be placed on your monitor or your laptop, whatever. So that's the way I wanted to like connect both of them. So instead of using screw, I just wanted to play around and try something. Yeah, so that's why I chose the magnet, and I just wanted to experiment with it because I've seen a lot of videos where people use magnets like join things. So I just wanted to try it out. It's like play around with it.
Oh, sure. Yeah. Oh man, magnets, the more stuff like I've built, even I would say particularly around the house, the more I've looked to utilize them whenever feasibly possible.
Yeah, yeah,
They're an amazing asset in the toolkit of anyone making anything.
yeah. So when it comes to like injection molding, this part I placed here for the USB, and then this actually drives costs up because you have to have like features going in that they are not like in your simple mode top and like bottom that you can just separate. So it's not really kind of like a good approach, but sometimes you can't actually escape this, so you have to do it anyways.
So I see so a lot of the draft here. What were the draft features added for in this case? Because this is 3D printed, right?
Yeah. So like I think I mentioned it before, like for this design, because
Mhm.
I'm trying to learn as much as possible as I can about like designing for manufacturing with like injection molding. So I try to like incorporate most of the things that are supposed to be like in a
Oh, I
main.
see.
Yeah, so and that's why I added the drafts. And when it comes to like injection molding, they're usually like uh, draft angles that you're supposed to use. So when you're adding a draft, you have like 1 to 3 degrees. This is mostly what's advised, but I've seen a lot of cases where people use 0.5 degree, and I've seen some cases where they go up to maybe like 10 degrees, depending on it's mostly dependent on what your manufacturer tell you, and it depends on like the texture of the material you're using as well, because this draft helps like the molds to come apart really easily, so you don't have to like you have your parts, they're still okay, because if you don't have this draft, it will be hard for the mold to come out. It will definitely come out because you have like strong equipment pulling them out, but it's going to damage your design, and you don't want that. Mm.
Interesting. Very cool. So basically, at this point, you mentioned you added the draft, of course, kind of keeping true to some of these injection molding tenets, and then also some of the fillets, assuming we're wanting to beautify the model a bit, and also kind of knock off some of the sharper corners, right?
Yeah. So one tool I use that helps me out when you're considering this for injection molding, because so basically we're like done with this part, and what you need to do is okay, check, evaluate if this is actually good for injection molding. So what I
Yeah,
do is
I mean, at this point, you have a lot of geometry, a lot of faces. Yeah, there's a lot to consider. It's no longer the box it once was.
yeah. So what I normally do is you have tools like draft analysis. So once you click draft analysis, what you do is okay, pick where you want to have like a pattern line where the two metal pieces, like the for the mold, should like meet. And for this, I kind of like chose this place. This is like just to play around with the tool, and then you choose where you're pulling the mold towards. So if it's going upwards, this is the arrow, or downwards, you can change it here, up or down. So let's choose up, and then this the degree of like draft you want to like check for. So here I normally put like maybe 1, because that might be like the lowest draft angle I currently have in the design. So once I do this, I can see other draft angle. It makes sure that whatever draft angle you have, it's like from 1 and above. So you click calculate, and then the green tells you that okay, all the surface are actually drafted and you're good to go, while the yellow is like okay, required drafting. And then the negative draft is like the other part, like the opposite side of the mold, which is supposed to pull towards the other side, because you have two molds like pulling away. And if you switch this sorry, so you have this like negative. So
I, I wonder if I think the face may have flipped twice, and then when you click calculate, I wonder if it recalculated again.
okay, so if you flip it and do recalculate,
There
it
you go.
changes, yeah, to the other side. And this basically shows that okay, what I have here is okay. But like I said before, you have problems with stuff like
Mhm.
this, which you have to have like extra piece to do it, including this. This is going to be like a huge problem, because you have to have tools going in here. This ones which you can talk about that with your manufacturer and try to like change stuff. But since I'm 3D printing, I can like bullshit that and just do what I
Sure.
want to do. Yeah, I
Yeah,
just
yeah,
yeah.
it's cool to see that, like, again, even though you're not injection molding in this case, you're trying to kind of keep up with proper practice, which is cool.
Yeah. So another thing you have to also consider, you see this place, this edges, they have like problems here. So you
Hmm.
also have to like, talk with the manufacturer about that. In some cases, they could go ahead and make this with this issue and you still have like a good part. But in some cases, it won't work out that way. So they actually do like a whole lot of like plastic molten flow to like see what happens, see if you have like problems and stuff, and then let you know if this can work or not. So yeah, in some cases it will, in some cases it won't. Most cases it won't, but
Very cool to see. I mean, this is like this would be a great like training model as well. Like I think this could be even just this video. I think could be very good for anyone that's looking to get into some injection molding potentially. This is a really neat practical model.
so I'll try to go a little bit fast because we're kind of like over the time
I
right
mean,
now.
it's what you're passionate about. I mean, that's very cool. But I appreciate the rest, that you guys watching. We're past the 1 hour mark, as Sunday mentioned here, but very good stuff. Very good stuff. We'll chapterize this so you can jump ahead to this if you want to. Kind of see some of the 3D CAD design methodologies that Sunday's went through with the project. But once again, thank you, and thank you, Sunday, of course.
Yeah, so I normally like to explain a lot so someone understands what
That's why we're here. It's great.
and that takes time. So yeah. So another feature you can use is like the thickness analysis. I mostly don't use this because I try to like try to be cautious of whatever I'm doing, so I know
Sure.
I'm like the thickness limit.
I mean, it's a great tool. I mean, that evaluate tab is full of just full of great tools. I would say thickness analysis is good for a lot of reasons. I mean, of course, like you said, if you just made the part yesterday and you were very cautious, then somewhat reliably you're probably fine given whichever requirements you have. Some of which you've mentioned for different types of parts, different types of manufacturing methods, etc. But sometimes, you made the part like a month ago or 2 months ago or longer, or someone else made it, or it's an imported part. So having this tool available, which does work with imported parts and neutral file formats, is really nice.
Yeah, yeah. So I basically just use the thickness feature the way it is. Just here you have two options: show thin regions and show thick regions. So it basically considered this and tells you if you have like parts that are less than this, you have like components that are the wall thickness that are less than 4 millimeter, or you have and wall thickness that are greater. So here I'm trying to like limit between 1 and 2, but it could go up to 3 depending. But so that's why 4 is like a good way to go. And then I say show 10 regions. So it calculates, and most times this doesn't take long. It's way faster than this usually. I'm guessing it's because I'm running kind of low on memory or something. Uh, it's going faster a little bit. So basically, once you do this, you see like different colors, like similar to like draft analysis, but this you have way more colors. So this is what you have, and then there's supposed to be a bar right here that shows you like the and color scheme and then the dimension, the value limit, but you can just go around and then see what you have. So like all this region, you can see 1.9 millimeter like closely to, and you have this 1.9. Most of them, this is 2, you see. So it's within the range of like 2 millimeter and 1, what I wanted. So you're good to go with this.
Yeah,
And
I think my audio cut out there, but yeah, it's a great tool. Like I was mentioning, I think for all sorts of reasons, imported parts. But yeah, you mentioned it usually does run pretty quickly. I think it's yeah, and this part, it's so interesting to me sometimes how some parts that might look simple from the outside, especially like just the exterior, are not as simple, right? When you look inside, especially injection molded or like injection molded looking parts, because you have a
yeah.
lot of faces, you have a lot of edges, you have a lot of stuff that's going on in the interior, of course, to give it structural, structural stability, to be able to have different channels for fasteners, different channels for different cords, for in your case, magnets. Like there's like there's a lot of stuff going on. So, but cool. The evaluate tab's full of like great tools like this.
Yeah. So we also have this undercut, but I'm not going to click it because since my the thickness feature took a lot of time, I don't want to try that right now. The undercut actually it's useful for when you're like using snap fits to like put in
Mhm.
place. So it tells you if it's like a good position where you can injection mold it easily, or you need to like put a cutout to allow like so it takes more time than like most of the features we have here. So you actually get a better explanation if you go online and just check it. But basically that's what the tool does. It's mainly for your snap fits. And one of the reason I didn't use snap fit here is because this is like a very small component, and I'll be using 3D printer, and 3D printers are not really that great for snap fit features, especially when the snap fits are going to be like very small. So that's why I decided to use screws instead of that.
Mm,
Mm.
that makes sense. That makes perfect sense to me.
So now we're going back to the assembly model. So the base part, it's basically the same as the top part. It has less components. So the same draft analysis you do here, and this is actually way easier because everything is just perfect for injection molding. So you don't have a problem here. So I won't go through this because I already did showed all the features with like the uh, top part. So
Yeah, it's pretty. Even I was just kind of looking at the feature tree. It seems pretty similar. It seemed like you had like most of your base stuff already done, and then you just added like you had done in the previous model.
yeah,
You added some draft, added some fillets, and you kind of capped it off there.
yeah. So let me hide this. Now, when you come to this model, you have to like place most of your electronics. And what I did here, in some cases, like they normally use like glues or fasteners, but the components I'm actually using don't have like the holes are too small for me to like use the screw, so I have to like find a way to go around it. And so what I did was I tried to like design parts I could use to
Oh, I
like
see. So you had to
yeah
make like kind of custom little bits of hardware.
that I could use to hold it. So this actually holds the DC converter, and then
Oh, cool.
you have this pins to like
Ah,
support.
that was smart.
Yeah, and this pin was actually made using that same boss feature. Yeah, so you can easily put that in there, and then you have like cutouts here, so I can like do whatever I want, and then there are holes here to like connect this to the top piece. So this connects to the top piece, and then this I actually use like a glue to like hold it to this base piece, and then I have this piece down here to
Uh-huh.
help support this, so it holds it in place.
Oh, yeah.
Yeah, as well as like since the glue is already holding it, but this kind of like supports it. Yeah, and then this was actually done. So because the LED strips they have like a glue under it that you can use to like glue to something. So
Mhm.
I designed this piece so I could glue the LED strips there, and that would kind of like hold it, and then screw it here just there. And then there's an acrylic sheet like I mentioned before that's here, kind of transparent. Uh, so this is it. It's the blue piece. Okay.
Okay, so you've modeled the glue piece.
Yeah, so it's actually transparent because I added the acrylic material to it.
Gotcha.
So yeah, once I click
Yeah,
it,
I
you see.
saw it. The dynamic highlighting showed me, but otherwise I wouldn't have seen it. I just would have thought it was empty space.
Because I added like a glass feature to make it transparent. So yeah, this is it. And so once I put everything in place, I could just like mount everything. there.
Gotcha.
And yeah, so this is what connects to the monitor, and you have this like it moves so you can adjust it, and you have like a screw and stuff to hold it, and based on how much you tension this will like hard to move. So one thing I did consider here when I was designing this, I also consider like injection molding this. And one thing is, like I mentioned before, you want to like maintain kind of like a particular thickness. And to do that, this has to have like somehow like fins. So
Hmm.
you have that.
That was exactly what that was gonna be my question. I was like, what's up with the shape here?
Yeah, so I have like uniform thickness with what I want, and then I don't have to like go against the injection molding rules or something like that. So it's easy to like manufacture, but I still have the surfaces all around to like make contact with the monitor I want. So that's part of like what I consider, and then probably along the line and still make adjustment to it. So this it's the project is still something I'm working on, like making a lot of changes, because when you actually 3D print parts, then you notice that, oh, this doesn't go, this doesn't fit well, and then you have to like make changes. And I do actually have some components I've actually 3D printed, and mainly the place I have problem with right now is just this and this. I haven't 3D printed this other piece, and the reason why is because these are like really small components, and this is a small design, and I'm trying to fit everything. So mostly I'm having issues with like this being too small, and then the 3D printer doesn't really print it well.
Oh
And
man.
yeah,
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 I know exactly what you mean because it's like it's the it's an age old problem, right? Maybe I would say a byproduct of CAD design. This isn't necessarily a problem. Sometimes it can be a nice thing, but like you can make anything as big as you want on the screen, and then it looks fine.
yeah. Like I always mention is that your manufacturing method plays a big role. I could 3D print this on like maybe SLA printers, and I will get like a really fine good part, but for FDM not so much.
Mm.
So if I do this with SLA, I might have like a really good print that's good to go. But because so yeah. Uh if it's okay with you, I would like to like show some of the parts I have with me here.
Yeah, let's do it. I'll if you have them, I'll show them full screen and everyone can take a look.
Okay, so I actually have them.
Yeah,
With,
let's take a look here.
so this is like this is the base part, and as you can see, you have like the threaded inserts in there.
Yeah, this is the moment where we're all, thinking, "Oh, I've seen that before somewhere." It was only in CAD, now it's real. But I see, okay, so I can see even as you rotate it, I can see the threaded inserts.
Yeah, so they're kind of like brownish or something.
Yeah, I see them.
Yeah, so I actually did this using a soldering iron, just
Uh-huh.
heat it up and then melted it in there. So that's basically what I had to like do for this part before like putting other components. And then the top part, this is the top part. So you have like the
Yeah, I
part,
see the ports, the magnet holder area.
yeah. And then I also have two threaded inserts there, and
Yeah.
this is meant to like hold the support I showed before, that's supposed to hold the DC to DC converter. So that's where you put it on, and then you can connect other components to it. And this is the support for the DC converter, and then the uh, yeah. So
Well, it's just like, you look at it, you can zoom in. I brought you back here just because,
mm,
it's such a great illustration. You're holding it up in your hand, and you can zoom in for as long as you'd like, and you can make it look as large as you'd like to. But at the end of the day, it's this big, and that's what it is, right? Like,
Yeah, it's very small. So
Yeah, and like seemingly, it's thin too. It's very thin. It can be potentially fragile.
yeah. So that's why that's where like dimensions play a role, and as well as like the material you're using, and then the
Mhm.
manufacturing that plays a big role. So I guess like because this is like really flexible, but it doesn't
Yeah,
really.
I'll make you full screen again. Yeah. So
So
it's okay. Yeah, it's very flexible. Yeah.
So, and I'm guessing it's because maybe it's PLA, you can use some other
Mm,
material that might be stronger, but for this purpose, it does what I want. And you could play around with the thickness, but I'm trying
sure.
to distance, the dimension is like a big constraint for me. I'm trying to like make it like very compact as much as possible. So yeah, I just have to play
Yeah,
around
and
and squeeze.
not too brittle.
Yeah. Mm. And then you have this piece, which is the one that kind of like holds the
Oh
uh
yeah.
yeah. So this is like light. It's very flexible, which doesn't really matter because you don't really have heavy components in there. So yeah, it's
No,
good.
it's like this is like the point in the show, like where it's like at the end of like a play or something where you see the actors. It's like, oh wow, like these guys. We watched them the whole time.
Yeah, yeah.
No, it's cool to see the components that you've printed out. And also good to know, like we're kind of seeing it. It sounds like you're like 85 to 90% of the way there.
Yeah. So I just have to like do a couple more prints and then like tune in, and then everything is okay. There are cases where I do a design and everything is like completely okay, and I print everything, it fits, and it's just good. But most times, like 90% of the time, you always have things you have to like go back and change and stuff like that. I think the one of the design I worked on, which you showed, was like uh what's it called, headphone stand.
Oh
That's
yeah,
like yeah, that's like a design
isn't
I
it in the
did.
background?
Uh,
Is that it?
yeah, that's it.
Yeah.
That's a design I did. I actually printed once, and the two components fit, and that's basically because of like experience. I just had like I have basically just two components: the black piece, which is kind of like a V, and then the main body. So I just used the experience of how I know my 3D printer clearance and stuff, and just added it, and it's fitting okay. It's like a perfect fit. You don't even need to use a glue. You just press it in there, and then it fits. It holds up. So that's nice.
Cool. Is that is that it as far as CAD, or is there more CAD there?
Oh, that's it for CAD.
Yeah, I figure we'd seen all the components and everything. But yeah, man, any parting words? I mean, we're wrapping up here. I just wanted to say, of course, we mentioned it at the sort of more towards the beginning, but once again, you alluded to your headphone stand. Of course, we talked about some of your other designs. We did a deep dive on one of the enclosures you just made or in the progress of perfecting. But yeah, check out your LinkedIn is how I became I came to know you. I became aware of you. And of course, we talked since, but yeah, you have a lot of really interesting, diverse array of designs. Some enclosures in there. You have, I believe, a pill organizer, portable SSD. Yeah, so a lot of different stuff here.
Mhm. I
Um,
try to like do diverse projects just to like improve my knowledge about stuff, and I try to like target mostly on my LinkedIn page mostly students, because I know how hard it is to like find information online and stuff like that, and most things I actually learn late. So I try to like engage with people. So as I'm learning, I'm sharing, and then a lot of students actually hit me up on like LinkedIn, send me messages, and then I try to like reply back. And if I'm unable to, maybe later on when I'm going through like my messages and I see it, I just try to like send them a message back. And it's quite good to like connect with them. So
Great. Well, everyone, give Sunday a thumbs up here. Say thank you in the chat. Thank you for me to you, Sunday, for sharing your knowledge here. I had a lot of fun. I learned a lot, and man, it's a great way to spend a Friday. For about an hour or so, just spending some time in SolidWorks talking about a project. So I had a lot of fun. But I think from all of us, Good luck, of course, with your new job. I'm sure you're killing it out there in Kansas City. And yeah, we hope to see you again on another live design. But once again, any just last parting pieces of advice, or of course, any one of us should connect with you on LinkedIn. But yeah, any last words here?
Okay, so what I would like to say is stay curious and try to always like watch design videos. That's like really good. It's really helpful. You might not know when you need them. You might think it's just something trivial, something you just saying, but later on you see they come in handy. And always learn about manufacturing a little bit. I find it plays a lot of role in like the industry because a lot of people will ask you about manufacturing, even if that's not what you're going to be doing, because the knowledge helps you to design. So try to learn a lot about that, especially injection molded, because that's what is used a lot in the industry. Uh, I think just play around, have fun, do a lot of projects, 3D print stuff. You learn as you go. That's what I do. That's what I constantly do. So that's just try to play around with stuff. Have fun. That's the most important thing. Because once you're having fun, it's easier for you to learn. So just try
Awesome.
to.
You have if you have time, one question here in parting. How long did this design take you? And on average, how long do your projects take to design, as well as making estimations on turnover time?
Okay, so it depends on like how like when I want to like complete the project, but most times I like to like take my time with projects that like take you have like a lot of components that you want to integrate into the project, but I try to do them within a month. And most of my design, the fact is, if it takes longer than that, it's because maybe I actually like put it aside to do something
Sure.
else. Yeah, but because I always come up with models, and once I have like sketches, I always try to go as fast as possible, have them in SolidWorks, and just dump them, and then later on come back when I have the time. Because right now I have a lot of CAD models on my laptop that I haven't even shared on LinkedIn because they're like projects I keep working on, and I'm always constantly coming up with ideas to like do something different. So that's like a cost for me. And to do that, I just do sketches and just do a card model and keep it aside. But normally I try to like do my stuff within a month, especially right now that I'm working with a medical device company. It's a fast-paced company. So you
Mhm.
have to do things faster. And I end up like designing most of this in like within a week. So when you're talking about enclosure, depending on how far they want to go, you just design something within a week. You're done. You prototype, you see, and try to see, okay, what's the fault here? What's this? What do you need to change it? Then you go back and do that. So it's the time frame basically is just how fast do you want this product, and then what's actually feasible. Mm.
Makes sense, man. Thank you so much for the final words of wisdom. Once again, follow Sunday Ochedi on LinkedIn. Just search his name. We've put it in the chat as well. And hey, Sunday, it's been great talking. We'll have to have you back. But once again, take care, and we'll see you all soon.
Okay, have a good one.